the focus of today's lecture is to think about, we have data, right? People have gone out and collected it. I've shown you the SDA website where you can get those large omnibus social surveys like the GSS or the American National Election Studies. So you might not have to go out and collect the data yourself. But you have it, and now you need to know what to do with it. So the first thing we're going to look at today is, how do we describe the data that we get? What is an easy way to look at it? And what I want you to think about with data is how data is distributed. How is it that we can look at it and to see how the data is sort of spread out or allocated among the different values of the variable? Now, how we look at the data will depend upon the shape of it. And when I say the shape, I mean the choice that we made or somebody made when they collected it on what type of data it's going to be. So we're going to keep that in mind. If it's ordinal data, we're going to look at it slightly different than we would as if it's a count data or a continuous data versus a dummy variable that is just a 0 or a 1. Because we could, again, with statistics, you can force a computer program to give you a distribution of the data that makes no sense. But the computer will go ahead and do it just to keep you happy, even though it's not the best way to look at it. Now, the first one I want to talk about is frequency. The frequency in which a number appears in a data set. This is known as a scatter plot. Write that down. Scatter plot. If you had to say it looked like something, what does the scatter look like? According to Joey, it's a bunch of dots. Yeah, it is a bunch of dots. I can make the dots like little triangles. I can make them diamonds if you'd like. I can change the shape of them. I can change the color of them if you'd like. But we've just got a bunch of dots. Anybody else see a pattern in this scatter plot? Okay, Tom says that there's some, Tom, right? Tom says that there's some straight lines. But they're not complete lines, right? No. What would the lines tell us, do you think? I haven't even told you what the data is yet, so. Okay, we'd see some tendencies, right? So let me tell you what this data is. This is feeling thermometer data on Hillary Clinton in 2008. So this is Hillary Rodham Clinton 2008. And respondents were asked to give Hillary a score between 0, representing cold, and 100, representing hot, on your personal feelings towards then Senator Clinton. Okay. Now, they weren't told this is Fahrenheit or Celsius or anything like that. Let's not get too hyper-technical on me. They were basically just told, give me a ranking between 0 and 100. So where do we see the lines? Lots of them might be, we're not certain, they might be round numbers. So if you look at 0, it appears that there's a line here. There's something like a line there, a line there, there's a line at 40, there, 60, there, and 100. So if we look at this sort of data, it's a continuous data set, right? Because it ranges from 0 to 100. Not exactly negative infinity to positive infinity, but we have a very good range of values here. We can see that people, each individual dot is a person. There's over 2,000 people in the data set. That's what the x-axis over here is our respondents. And so we have overlapping dots because they're really close. We can see that people tended to select 1, 2, 3, 4, 5, 6, 7, 8, 9 values. Right? There were 9 values that stand out between the 101 possible values that most people selected. Does that tell us anything? Okay, so maybe there's some evidence of rounding, right? When we're given too many choices, like you're given 101 choices that range from 0 to 100. That's 101 actual numbers you could have chosen. We see that a lot of people chose certain numbers. There were these 9. Maybe they're round numbers, right? You think they're all like multiples of 5?
Yeah, it looks like it.
They could be. Right. If I did individual ticks on the y-axis, if I built a more complete graph, we could maybe count and figure it out. Is this very useful? To anybody?
It tells you that 2,500 people, what a good portion of each, or like several people voted on. They liked her, so you can use it as a representative of the country, saying that a lot of people didn't like her.
Okay.
Well,
let me ask a question, Jake. You say that a lot of people didn't like her. How do you know that?
Well, out of 2,500 cases, there's a lot of solid dots on 0.
All right. There's
15, 20, 40, and 50, and then equally about number of people liked it in 60, 70, 85, or 90, 100.
Okay. So let's take notice of 2 things that Jake did. One is he took the 101 options and you essentially boiled it down into 2, right? So in his mind he recoded this and he said, well, there's a group of people that don't like her, and then there's a group of people that like her. Is that a fair representation of what you said? Okay. That's the thing, right? We have way too many dots on this. And we have about 2,300 dots here. And because of the way that we reproduce this, we can't really tell the numbers, right? We can tell the groupings, but we can't tell the individual numbers. So there must be other ways to take this data and look at it to see what is actually represented in the 2,300 observations. So this is a scatter plot. It's a quick way to visualize your data to sort of see what's going on. Sometimes when we do a scatter plot, we can see a pattern, sort of like a cloud, or you know how when you're laying on the ground and you're looking at clouds when you were a kid, and you're like, hey, that's an umbrella, that's a car. You can see patterns in the clouds. Well, you can do the same thing with data. So what we're going to do now is, instead of just looking at this scatter plot, looking for clouds or shapes, we're actually going to create a table. The table is known as a frequency distribution. The frequency tells us the number of times each value occurs in the data set. This is just a very simple list. It's a counting. So when we construct this, where are we going to start? Let's start at the bottom. What are we going to look for? If we start at the bottom, what's the bottom value? 0. We're going to look at 0, and then what are we going to do? Count how many times somebody responded with 0. Okay. So here we go. This is stata output for that variable. How many people said 0? Reading the chart that's on the wall. 124 people out of the 2,306 said 0. Okay. Now when you display a frequency, I put the 3 most common numbers that are done in a frequency table. The first number is the raw count. It's the actual number. The second number is the percentage of the total. So of the 2,300 people, 2,306, 5.38% gave an answer of 0. So that's why we saw that line there. Now we couldn't tell how many gave the answer of 0. We just thought it looked like a lot, right? Because of all the dots that were overlapping. Now we said there were 9 lines. Where were our 9 lines? Well, it looks like, using the percentage column, we had at 15, at 30, at 40, 50, 60, 70, 85, and 100. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are our lines in the data that we saw. We saw that people tended to these groupings. Are they all on multiples of 5? Yeah, right? Just like Tom thought. They're going to be multiples of 5. So is that a potential issue with using feeling thermometers? That we're giving people more precision than they can use? This is why people around the world don't like the Fahrenheit scale for measuring temperature. Because you ask somebody, they'll be like, oh, what's the temperature today? 81. 81 sounds very specific. But can you tell the difference between 81 and 80? Can you feel the difference between 80 and 85? Some people claim they can. I don't know, it just sounds hot to me. Nick and I are on the same page. We're like, no, it's 80, I'm sweating. It's 85, I'm still sweating. Yeah. But people who grew up using the Celsius scale can feel the difference, allegedly, I think they're liars, between like 15 and 16. Oh, it's 16 out. I don't know if that's hot or cold, but whatever. Right? They claim that they know the difference. Why? Because it's a meaningful difference for them. Again, they're Canadians. You can't trust them. But you'll notice most of the world uses Celsius. Very few countries use Fahrenheit. Right? And it might be an artifact of this idea that there's really not a lot of difference. Can we tell the difference in our feelings towards Hillary Clinton between an 8 and a 10? One person was like, I'm an 8. What is the difference between an 8 and a 10? Again, what's the difference between 81 and 82 degrees Fahrenheit? It's measurable for that person, but is it really a distinguished difference? Probably not. Back to a previous lesson where we talked about measurement as a theory. How could we convert this count variable into something else that would give us perhaps more meaning? How could you take this variable that ranges from 0 to 100 and change it? Danny?
I don't know if this is right, but could you make it like ordinal where it's like light is like neutral, like that kind of thing?
Sure, right? What she's suggesting is we take this data and we divide it up into different categories. So Danny, where are you going to put the cut points? That's what they're called, cut points. 10 and under.
Yeah, 10 and under.
Okay.
And then like 15 to 35
Sorry.
would be, I guess,
15 to like 35 is a dislike.
then 40 to 60 is neutral.
Meh.
And then 62 to 80 will be like, and the rest is
Okay. Not bad. What did Danny, how did you make those cut points?
I just kind of like broke it up.
Okay. We've got some value ranges here, right? This is 10 points big. This is 20 points. This is 20 points. Let's call this 61 to 80. That's 20 points, and that's 20 points. I must have lost some points here somewhere because math hard. I lost 5 here, and I lost 5 here too. Right? So we could have better cut points. But you could basically take this and divide it into, here's a fancy stats word. Ready? Quintiles. Anybody know what a quintile is? It's a fifth of something. It's 1/5. Or 20%. There are people out there that actually do this to their data. They look at it and they go, well, I'll divide it into quintiles. But when they do quintiles, you can either do it on the actual value itself. So what you've done is taken the 100-point scale and turned it into 5 20-point values. Or sometimes what they do is they let the data show you where the cut points are. Because we assume that there are 5 values. And that's where you can come over here. My eraser's not really working. Watch this. You can come over here and use this cumulative frequency. And the cumulative frequency starts at 0, and then it adds up each successive value. So 5.38 plus 0.04 equals 5.42. And then you just keep going. And what the quintile people who would do it based upon the frequency distribution would do is they do this in, here's your actual 20th percentile right here. Your 40th percentile is somewhere around here, and then the 60th, and then the 80th. And there are your 5 groups. That's another way of doing it. I just say, let your data be your data. Just leave it alone. But if you wanted to assign values, if you want to take it from a count variable, or excuse me, a continuous variable with a range, and you want to condense it down into categories, Danny can say, well, this is nice, but to me, there needs to be a way to distinguish the loves from the likes, from the mehs to the don't likes to the hates. And that's what she's really interested in. That's a choice that she as a researcher would make. Okay. So this is a frequency distribution table. Like I said, there are other measures that you can put in, but these are the 3 most common. The actual frequency, that frequency as a percentage of all of the data, and then the cumulative frequency, which is adding up the percentages, starting at 0, working your way up, all the way down to 100. This is what we do on a standardized test, by the way. So that's why it's a standardized test. It's not standardized because a group of people all take the exact same test at the same time. Something like the LSAT or the GRE, the scores are standardized, which means the distribution of the scores that they give out are fixed according to this sort of distribution that they set up ahead of time. All right. We all cool on this? One way of looking at this data. Okay. Now you can use this percentage or proportion to compare across groups, right? So if Danny has set up her groups into 5, she can compare then the size of the groups to each other. Which group is bigger, people who love Hillary or people who hate Hillary? Well, we need to go back at our data to look at that. All right, where were the haters, Danny? It was like 0 to 20?
Yeah.
That's 10%. And I think you had the loves at around 85 and higher. That's 14.31%. So which group, according to Danny's classification, is bigger, lovers or haters? Lovers. Okay. So Danny could make the following statement. According to data from the 2008 American National Election Studies, more people love Hillary Clinton than hate. And that would be a factual statement, correct? According to her classification system. She would say those who love Hillary Clinton gave her a score of 85 out of 100, whereas those who hated were in the 0 to 15 range. She would be making the argument to the reader or the audience of how she constructed her variables. She could also make an argument, let's say you disagree with her and you go back to the raw data. More people gave her a score on the 50 and higher than the 50 and under. And that's about 66% to 33%. If you want to use that 51 number, which nobody selected 51, because they probably didn't realize this was a 101-point scale and not a 100-point scale, because everybody always forgets about the 0. That's why a bunch of people said 50, because they thought 50 was the midpoint between 0 and 100. And they're wrong, because it's not. Actually, 51 is. Well, 50.5, round up 51, do it that way. Or if you want to do it as the median selection, that would be the 50 actually would be the median. Because you got 50 above and 50 below. Well, anyways, we're close. I've been myself wrong. All right. Here we go. So that's maybe the midpoint, maybe not. We'll have to do midpoints next class. All right. Let's take a look at something else. Now, we have percentages, and what we've done so far is just looked at the percentages based upon the values of one variable. Right? The one variable was the Clinton score, right? The Clinton feeling thermometer. So that describes the data we have, but we can't really make any conclusions about who likes or dislikes Hillary until we add at least a second variable. Just looking at the data this way and adding a second variable is known as a crosstab. So if we want to look at two variables at the same time, we'd have to create two frequency distributions. Now when we do this, the columns of our crosstabs are going to be our independent variable. Our independent variable is the one that we're trying to use as an explanation. So give me an example that has two choices of an independent variable that you think might factor into whether or not you like Hillary Clinton. Whether the respondent is a Republican or a Democrat. Okay. What else? Okay, let's go with male or female. I'll include them both here because we would expect Democrats to be more like give Hillary Clinton higher scores, and we would expect females to give Hillary Clinton higher scores. Why would we do that? Why would we expect Democrats to give Hillary Clinton higher scores? Because she identifies as a Democrat. Okay? And if you take a political parties class, you learn that partisanship is a driving factor in vote choice and how you view questions and people, ideologies, attitudes are all constructed around partisanship. What about the male-female thing? Why would females be more likely to support Hillary Clinton than males? All right, Alexis says she's a so-called feminist. Put up the scary quotes. She is a female. She has that, right? And that's known as the representational theory of democracy, where we tend to vote for people who look like us because they represent our interests, because they have the same body parts as us, or they look like us. Okay? If they are the same with us, then they must share the same values. Okay. The rows would be the dependent variable. Danny's already constructed this love and hate. Okay. She's taken a variable that has 101 selections. She's boiled it down to love and hate. Then there's a couple other ones, right? We could ignore the mez. And we could change these two categories to like and dislike. We could use that cut point in the middle to do like and dislike. Right? You, as the researcher, define what these terms mean. Now, in order to do this, to compare the two groups, I gotta have a number. I gotta have some number to represent what it is that I'm comparing. And this is where we're gonna move to an actual statistic, something that gets generated. Finally, week 3, a number. One of the first things we can compare is called a mean. Mean is fancy statistics talk for average. And if I want to make your brain hurt on the first day, how do you compute the mean? I'll tell you to do that using exclusively letters from multiple alphabets. The average value is the sum of all x's. X is the variable we're looking at. What's the variable we're looking at in this case? Hillary's temperature. And we're going to take that number that we get, and then we're going to divide it by the number of x's, which equals the number of respondents that we had. So I can get an overall number of whether or not people liked or disliked Hillary Clinton. So I was playing with this data earlier in Stata, and the average score of liking Hillary Clinton was 62.9. So, on average, how do people feel about Hillary Clinton? According to Danny's scale, we're in the like category, right? 63, she had a cut point at 60. On average, most respondents the average respondent liked Hillary Clinton. Let's take a look at this by gender. I didn't prep this, but we'll do it really quickly. All right, here we are at the SDA website. We'll go into the archive. This data came from the 2008 National Election Study. And one of the things that's neat about this website is it will do some very simple calculations for you. So you didn't have to download the data and then put it in Stata like I did. Right? Because you guys don't have Stata. It costs $400. It's not free. But you can use this to get some information out from the data set. Okay. I've got the number for the Hillary variable, but I need to find a number for my gender variable. So I'm going to open the code book. Okay. And here's the code book, and I need to find something that gives me information about the respondents. Here we go. Non-survey data. Let's go back. Study weight, sampling, free election, survey data. Maybe I should have searched. Maybe I should have gotten my act together and did this before class. Maybe, maybe not. Here we go. 38. Okay, hurry up. Interviewer gender. Don't want that. I want respondent's gender. Come on. Let's household gender. Let's try this one. Let's try this V08101. Let's copy that. All right, go back to analysis. Gender is going to be my columns. And my row is going to be this variable number. Please, Lord, do something. Okay. Means. I wanted the means. Sorry. Row. Dependent variable was this one. It was just doing it for every value. And I don't want that. I want to compare the means. Yeah, I really should have done this ahead of time. I don't want a bar chart. I want the here we go. I'm getting closer. Yeah. All right. I shouldn't have done that. Moving on. I'll show you a better example next class when I actually plan this out ahead of time. Okay. That's the mean. Mean works best for variables that have a large range, like count variables, continuous variables. You could do it with ordinal variables because, again, those numbers have meaning, like 1 through 7. You could do a mean for an ordinal variable. You can't use a mean on nominal level data because the numbers don't mean anything. Our nominal level data was things like hair color. And although you can impose an ordering on them, you look like a jerk when you do that. Oh no, it was eye color that I did in the last class, right? I said blue eyes were best, and then green, then brown, then everything else. That was my ordering that I put on top of it. But really, those are nominal level. The median takes into account all of the observations. Now, we had how many observations in our data? We had 2,306. That's an even number. That divided by 2 equals 1. Oh, I'm not even going to look like an idiot. I'm just going to use my calculator. 1 what? Thank you. Okay. So we would go and look around this number of observation to see what the value is. I can do that. I have a data set. I'll go look for the 1,153rd and see what numbers are around it. 1153. So I'm back into Stata where I have my data, and I'm going to sort by the ID number. And then I'm going to look at my data. Here's the data sorted by ID number. Or I could sort it by the value that I'm actually interested in, which is what I should have done. Let's close that. Sort by that's better. And now I'm looking for the observation that is 1,153rd. There's a command that'll tell me what the value is, but to show you, just take a minute. Okay, so what is the median score? 70. Okay, I'm ballparking it. I'm not going to divide and take the number higher and the number lower and then divide it by half. I don't need to do that. I know it's 70. So what does that really mean? That the median value is 70. If we think about the continuum from 0 to 100, where's the middle, the median? The median is actually at 70. That means half of the observations are greater than 70 and half are less than 70. So 70 is the number that the whole group settled around. Now, I hate to throw this on top of this, but remember, there are other ways that we can represent data. And one way to represent data is by a distribution curve. So if I were to draw a curve of this data, it would look like this, with the middle, the area, representing half below 70 and the other half above 70. And so the highest point of that curve would be the responses that are 70. Okay. The last type of way to condense data down and have it represented is called a mode. The modal category is the category that is seen most frequently, the one that you have observed the most. And this is perfect for nominal data. It is essentially a count. Which one had the highest number? Now we're going to go back and we're going to look at the modal response for Hillary Clinton. Let's see which number appeared the most times. Which one appeared the most? 85 appeared 440 times in 19% of the respondents. Nothing is higher. So in summarizing this data set, we've given ourselves 3 different numbers to look at. The mean was 63. The median was 70, and the mode was 85. Which one we choose to represent our data depends upon the shape of it, depends upon the way that it was created and how we measured it. How did we create this? Well, this is a continuous type variable, has a long range. So which one do we think is the best? Which number captures most of the variation in all the numbers? The mode? No. The median? Mean? It's actually the mean. For this type of data, mean is the best. Because it allows for the full range of values. Okay, so mean is the best. A median is better when we have an order, a ranked order, and the mode is the best for nominal.